Hello ladies and gentlemen. Today I'd like to talk to you about why do passwords matter and how to make a strong one. Let's begin. Why do we need passwords? Well, they're really annoying, aren't they? But in essence, it's all about the good guys and the bad guys. The good guys want to use computer systems on the internet without having to worry too much about passwords, and the bad guys are trying to break into the same computer systems to steal our data. So, although passwords are a bit annoying, it's better to have them than not. What makes up a password? Well, as you probably know already, it's made up of characters, uppercase characters, lowercase characters, numbers, and symbols. You combine them all together and you create a password. Now, little note here, if the system needs you to create a symbol as part of the password, don't use the slash signs or any money terms like a pound sign or a euro sign, and don't use spaces. Reason for that is that a lot of systems get a bit upset with you, and very often they'll either reject the password or in worst cases they'll accept the password but ignore the characters, so you keep on putting in the password that you thought you created and it won't let you in. So try to avoid those. Let's have an example, one of the insane, silly examples that people give just to emphasize a point. Let's assume that we could actually use a one-character password to get into a system. Pretty much every system in the world won't allow you to do this, but as an example, let's go for it. And our password is going to be the letter E. Now, if I was a bad guy, I'm trying to find your password. And so the number of different combinations to get to the letter E is about 120 or so different combinations. So as you can see, if the bad guy just puts in A, no, B, no, C, no, D, no, E, yeah, I'm in. Very simple. But as most examples, this wouldn't happen in real life. In real life, what happens is that when you get past about 6 or 7 characters in your password, the number of different possibilities to try and randomly guess your password becomes insane. As you can see, when you get up to a 12-character password, the number of random guesses the bad guy would need to guess your password goes into the trillions upon trillions upon trillions, and therefore the bad guy won't have a chance of trying to find your password. As I'm sure you've discovered yourself, when you try to sign up to a new service like Amazon or Google, the system will actually ask you to create a password with a minimum password requirement. These are typically 8 characters or more, upper and lowercase characters, and using at least one number. Some systems ask for a symbol as well, but that's not so common. So in our example, my new password is Apple, spelt with a capital A, 123. That's a strong password. It has to be because it conforms to the minimum password requirement. Yeah? Well, no. These bad guys, they are quite sneaky. What they tend to do is they don't just randomly try to guess passwords, because as you've seen, when you get up to a password of 8, 9, 10, 11, 12 characters long, it's impossible for them to guess randomly. It's what they call a brute force attack. So what they do is they do something called a dictionary attack. What they do, rather than try and guess randomly your password, they'll take a dictionary of the top million or so commonly used passwords and then try them one at a time. If they don't get in, then what they'll do is they stick a number at the end, 1 or 2 or 3 or 1, 2, 3. So if you look at the example, our carefully crafted password of Apple123 gets found and discovered by the bad guy more quickly than you would necessarily think would be the case. The result is, please don't use a name followed by a number. It won't create a very good password. What will create a very strong password is the name number object rule. So what do I mean by that? Let's make a password that's strong and will be very difficult for the bad guy, shall we say, to guess. First of all, we need to pick a name. That could be a first name, a surname, a place name. In this example, I'm going to pick Mary. Now, A name you'd normally spell automatically with a capital letter. So we've conformed to the upper and lowercase part of the password requirement straight away. Then I'm just going to pick a 2-digit number, 53 in this case, followed by an object, anything that isn't a name. In our example, flower. So what I've done is I've then put them in order. So name, number, object. Mary, 53, flower. That's created a 12-character password, conforms to all the minimum password requirements, and because we've got a name, then a number, then another word, it's very difficult for the bad guys to actually break that password. It's not impossible. No password is impossible to break, but it's very difficult. What the bad guys are looking for is the simple passwords. The pencil 123 type passwords that they can break easily. Our example, they'll break eventually, but we're in the top 5% of password strength according to most systems. So we're pretty good. Just if the password system does ask you to put a symbol in, I usually put the symbol in between the two numbers. It just makes it the most difficult to crack. A few last thoughts. As my life as a cybersecurity guy, I've seen this so often, so please don't use the same password for multiple systems. It's a really bad thing. The example I give is, if you have the same password for both your Gmail account and your Amazon account, and you don't have two-factor authentication turned on, more of that in another video, then the bad guy, if they crack your Gmail account password, then the first thing they'll do is they'll use the same email address, which they've just cracked, to see if they can get into commonly used systems, Amazon being the first port of call for a lot of people. Because if they have access to your Gmail account and your Amazon account, at that point they can then start ordering stuff using your details. They can actually get stuff. They make money. And that's what they want. That's what they're striving to do. So please, pretty please, use a different password for different systems. And finally, the weakest part of any security system is not the antivirus that's on your computer. It's not the password strength that you have to access your system. It's you. You are very susceptible to fraud, to scams, social engineering in cybersecurity terms. It's very easy for intelligent people to fall foul of this. I've seen it dozens and dozens of times. The scam artists are very clever. They will try to influence you and get you to do what they want you to do by pressurizing you. It's very common that you'll get some sort of either telephone message, email, they may even knock at the door to say that something is going to happen, something's going to get shut off unless you pay us money or you update your details. So please be aware, if it doesn't feel right, or if you're being pressured into something, then just put the phone down, shut the door, delete the email. Anyway, hope you enjoyed the video. I'm Simon from Invicta Digital. Thank you.